Now, the next thing we're going to do is use another pop generator, and we're going to use this to play with the noise features inside cops, which is also pretty cool. Let's go here. And here the idea is we're going to be outputting the channels, the same RGBA channels. But let's start by generating anti-aliased noise. We'll convert the XY coordinates of each pixel. Okay, now we're not dealing with X, Y, and Z. We're dealing with XY because we're just dealing with planes and pixels. So we'll convert vector float to vector. We'll use a float to vector. Convert this X, Y. We can connect it here to the position. Let's have a look at. And now we can play with the anti-aliased noise. Same thing as before. So you increase the frequency and you can have real-time feedback of what you're doing. Play with the roughness, etc. Okay, first, not to have to connect these individually every time. What I'm going to do is I'll convert a vector to float. I'll use a vector to float just as a way of putting this in, and we're going to be using the same value for all the channels, so this just makes it easier. If I want to change what I want to visualize, we just need to connect here. Now, this is anti-aliased noise. Most of the time we want these three to be connected, so take care of that. So I'll copy this parameter, base relative references, and base relative references. That's taken care of. Let's keep this at 6 for now. If you want to increase, add more contrast, more grungy look, just increase the roughness. Let's have a look at another one. Let's have a look at the turbulent noise. Okay, same principle. So I'm going to copy this, copy parameter, base relative reference, and base relative reference. Let's say 2, increase the roughness here. Maybe try sparse convolution. You should try with all of these. Now this is nice, but none of these noises break out of the typical noise pattern. So what we're going to do is actually combine these. And the way to do that is by adding. We're going to add to the position vector of each pixel, again, X, Y. We're going to add this anti-aliased noise. Let me just disconnect here. Generate a 3D noise from this, and we're going to add this. And this is kind of it's going to be a distorted position field that we're going to be using for generating the noise. And as you can see, now we get a much more organic pattern, and this is much more useful than any of the previous ones. Pretty cool, right? Very rich texture. And you can generate this at whatever resolution you want. It's pretty useful. You can generate your own grunge maps, and you can see the influence that this has. So if we reduce the frequency to 2, see we get a different type of pattern, also interesting. But for now, I'll keep it at 4, something like that. Now, this is nice, but the problem I have with just using a random noise is that it would be nice for us to actually grab some information from our height field and relate one thing to the other. So the idea I thought of was grabbing the bedrock, which is basically a normalized height value. Let's go to bedrock. And let's connect it here so we can actually see what's happening. Okay, so this is basically the height value that we have. Okay, really nice pattern. Again, using real world data is always, height fields are great, but mixing both things gives you the best results, I think. Now we have the bedrock, and we can use the bedrock to kind of control some parameter on the turbulent noise, on the turbulent noise. Let's do a fit range. And in this case, we're gonna use it to control the frequency of the noise. Okay, so we know this is coming with a value from 0 to 1. And let's say the frequency is gonna vary between 4 and 8. And let's connect this to turbulent noise. Actually, let's create a different turbulent noise. Let's leave this here. Let's create a new one. And this is not going to use the distorted position. It's actually going to use just the regular position. And we'll use the frequency here. Let's see what this gives us. Okay, and as you can see, this gives us a really interesting type of variation. It's not, we can't really identify the pattern that we have on the bedrock by itself, but there's something there. And this is the type of thing that I wanted to combine with the completely random grunge noise that we had here. It would be nice to kind of find a way of mixing these two. Okay, let's see what we get if we change this to original Perlin noise. Something that I use very often, that I consult very often, is the help on the turbulent noise, mostly to understand what's the range of values that I'm getting from each one of the different noises, because each one of these gives you a different kind of range. So the original Perlin noise will be roughly between -1 and 1. And we'll use that. But as you can see, the Perlin noise will give you between 0 and 1. Sparse convolution is going to be between -1.7 and 1.7. So you have different ranges for different ones, and it's nice to have an idea of what's happening so that you can properly fit the range. In this case, I'm going to go with the original Perlin noise and try to fit it. Let's apply fit here. So it's going to come from -1 to 1, and let's have a look at it like this. It's going to get much brighter, but as you can see, we do have some information there. Yeah, I think this can be interesting. Now, it's just a matter of trying different things. I've tried a couple of them, and what I like to do is use this third noise with a fit to control the offset. And basically, this allows me to break up this pattern. Let me just disconnect it. So the pattern that we have here, we're gonna be kind of offsetting this interesting texture based on this noise, which is based on the height. So this should give us an interesting result. I tried it before. Let's use this as an offset. Now the values we need to figure them out, but let's say -4 and 4. Something like that, because -1, 0 to 1 wouldn't be much of a difference, wouldn't be hard enough, strong enough. And yeah, so now you can see that we have kind of some shapes are kind of seem to be following a bit better or closer to the natural shape of our terrain. Okay, we have, for instance, this ridge here, and if we look at this result, we should see something happening around that area, following those shapes. There's a shape here as well. And you can be more intense about this. Let's say 20 and -20. Okay, and it gets stronger and stronger that way. Might be too much. I'm gonna leave it at -10. or even 0 to 20, I think could be interesting. Yeah, I think this is interesting. It's definitely more related to the terrain than just this. So let's use this one.